Good morning, Madhuri.
Good morning.
Okay, so I have started the recording as well. Uh, and today, what we are supposed to do is introduction to Hadoop ecosystem. Okay, but before getting into that, let's just brief what we have done so far. So today, you guys joined from the dashboard or still from the mail itself?
Jayant, I joined from mail because the particular link is not available with my login.
Hmm.
I also joined from mail because some security versions or any other sites are not getting open to me.
So you were not able to log in from this thing. You're not getting this thing
For
only.
me, yeah, I'm not getting this thing. It's still saying I need to do the payment. Pay now option is active.
Yeah. So you're still not able to access your dashboard.
No.
Not possible. I had made your payment clear that day itself. Oh, it is still showing pending payment. How come? Okay, so yesterday was the first time you were trying it.
Yeah, I tried yesterday.
Okay, okay, no issues. Just give me half an hour after the class, and I'll get this corrected.
Okay. Yeah.
Okay, so I assume there's some issue with the backend, with the website coding wala part. So I'll get it
Hmm.
corrected in half an hour. So don't worry, I'll do it.
Okay.
So you were not able to go through the session documents and everything as well then.
Right.
Okay, my bad. So we'll do it, we'll do it. Okay, so this is the agenda for today. What is ecosystem, why ecosystem, then the backend working, introduction to popular tools. Okay, sorry. And Madhuri, what about you? You said security issues.
That is antivirus I have uploaded now,
Uh-huh.
installed. So because of that, if I disable that, then only GoToMeeting will work.
Right.
And that time, any other sites are not getting open.
Okay. So you'll always have to do from GoToMeeting itself.
Yeah.
Okay, no issues, no issues. Then I'll keep circulating the mail also. Okay, so apart from your introduction to big data and introduction to Hadoop, what we have done so far is we have done the basic of MapReduce programming, wherein we saw how to execute a word count MapReduce program, and then we have also seen this thing. What do you call? partitioner and combiner. So today is session number 9 on 16th of December. So we have completed one phase in our course. Okay, and in the first phase what we had, I can precisely call it as phase 1, in which we had introduction to and this first topic is to be covered for you, Mangesh, right?
Yeah.
Then second one, introduction to big data, then introduction to Hadoop. In this we saw the architecture, then the job process, then your different daemons. We also saw not installation. So I'm just writing the main points that you should be knowing. So we also saw installation in sudo, configuring Hadoop in sudo mode. Then we went into MapReduce programming, and we have completed word count ka program, then partitioner and combiner. Right, so this is what we have done so far, and now we would be getting into the second phase, in which we would be talking about introduction to Hadoop ecosystem, then Hive, Pig, Flume, Scoop, Oozie. Okay, so this would be our second phase of our course. Okay, so any doubts in phase 1?
No doubts, but just wanted to understand for the exercise point of view, do we have any labs on phase 1?
Yes, I have already submitted the labs for the what we have done so far. Uska lab manual I've already shared with you of configuring
Okay.
Hadoop in the sudo mode, as well as the word count ka program. Okay, partitioner and combiner ka video and lab I would be sharing today. Okay, and the
Okay.
assignments for this particular MapReduce programming will also be shared today.
Okay.
There are some assignments as well. No, no, I cannot show you that right now. So there are some assignments as well in phase 1. So I'll be sharing all those today. So you'll have to do it. And on Monday, coming Monday, we will have a test on whatever we will be doing. Uh, just let me think. if we do have a test on Hive. Okay, so today we'll complete this. Tomorrow we'll complete this. Hive pig. Okay, so on Monday we'll have a test on theory part of whatever we'll cover till Friday and practical part of MapReduce programming.
Okay.
Okay, so Saturday, Sunday again be prepared for the test. Prepare yourself nicely so that you score good numbers. Okay. Yeah, and once this is done, your dashboard ka problem is solved, Mangesh. Please do intimate me once it is solved, okay? And do go through all the
Okay.
documents and stuff that I have shared. So if you can see here in session 8, I have shared the session document, yesterday's session ka document. Then in
Mm-hmm.
session number 7, I have shared the session ka document, then word count ka lab manual, as well as the Hadoop ka configuration manual.
Okay.
Okay, and the virtual machine is already being shared to you via Google Drive, right?
Yeah.
So have you guys at least downloaded that?
Yeah, I have downloaded the virtual machine installer, the virtual machine RAR file. I need to download a virtual machine workstation.
Yeah. So you have not started working on it so far.
Yeah.
Neither of you. Madhuri, what about you?
Mm,
You have not downloaded as well,
downloaded but not started working.
right?
Not get the time to do
Eh.
the meeting.
Okay. So see, we would be having a lot of things hereafter. So every time you won't be getting a Saturday and Sunday for practicing. You'd be getting test in the midweek as well. So it is not compulsory that every time only on Saturdays and Sundays you'll be getting time for studying for the test. So please make sure that you start doing it. So this is your VMware workstation का installer. इसके अंदर you also have the keys, serial keys, and this is your actual Hadoop का this thing, virtual machine. Okay. You also have videos which will indicate how this is prepared. You also have videos which will indicate how this is prepared. If you want, what I'll do is I'll share all the videos and everything that is available on this drive itself. Whatever videos are available so far, or I can do this. So seven, na? So six videos I can put here. Okay. So I'll do one thing today. I'll share all the videos, that are in the free course as well in this particular all between all these sessions itself, so that you have everything in one place. So you don't have to, go here and there for getting all this stuff. Okay.
Okay.
Actually, we are working on this as well from the website point of view, that we'll be having a Google Drive like environment so that you don't have to go session wise. You'll have everything in one place itself. Okay. So guys, please practice, because without practicing, you won't be able to, it would be like I'm going from my side, and we are still in square one. So please do not let that happen, and please start studying. because what we would be having after that is your next phases wherein we would be talking about, okay, let's not get into this now. Module and everything is already there, so let's not get into this. Okay, so let's start. Now, first thing, tell me, did you find any disadvantages of MapReduce programming? From whatever we did so far, did you find that there can be some disadvantages of MapReduce programming?
It would be nice if we can have a single point of interface for all the services we are executing during the job execution. That could be
Means,
one. So we need to open three different windows, right? The Eclipse window, then your dashboard window, and for the web browser as well.
okay. Okay, so that actually becomes a disadvantage of core Hadoop. Okay, we'll be soon
Mhm.
having this on our own platform, but by the time it is there available on our own platform on the cloud servers, I'll show you here. See, this is HUE, one of the UI interface for Hadoop, which is provided by Cloudera, the distribution of Hadoop. Okay, so here you
Okay.
have everything at one place. So if you talk about your job designer, then you can create a new job from here. Just give the name, description, then the jar ka path. If you want to add some properties, add the input file. If you want to add a zip file, then you can add it here, then save it and then start running it. Okay. So here, this is the one place, one single browser wherein you will be able to see the file browser,
Mm-hmm.
the job browser, plus you can execute your queries as well.
Yeah.
Yeah, but basically this is a disadvantage already overcome of core Hadoop.
Okay.
Okay, and this environment within like next a week or so, you'll be able to see this on our cloud as well.
Okay.
So this is not exactly a disadvantage of MapReduce programming. It is disadvantage of core Hadoop. Specific to MapReduce programming, anything?
Uh, every time we have to run the program in a different for different uh, what is it?
In a different what?
Every time when we are running the program, we get the output in new folders. Or every time uh, when you want to run the program
What?
in your
Yeah, go ahead, Madhuri, go ahead. So every time I need, run a new program, I have to run it in a new, I have to give a new output folder ka name.
yeah.
How can that be a disadvantage? Huh? Can you please explain? Hello?
Yeah.
Yeah, why do you think that is a disadvantage?
for if for the single change in the program, or the same program when I have to run, then also I have to create the new output folders. Okay.
Okay, but actually that can be an advantage, right? Because if you're making even a small change, then you're expecting a change in the output.
Yeah, but if I didn't change anything and again I have to run that program, then also I have to create a new folder, right?
So if you are satisfied with whatever you have already in the HDFS, the output is already there. If you are satisfied with what is there, so why would you go for executing it again? And even if you execute it again and a new folder is created, so that can be used as a version maintenance, right? So possibly this feature, though it is not used for versioning, but still this can be a kind of versioning. See, disadvantage it can be in terms of space, yeah, that unnecessarily extra space is
Space.
wasted.
Yeah.
But talking about Hadoop, it is a large file system wherein space and time, these are the two things that are not at all of any consideration or of any importance because we have got it in abundant. Okay. Secondly, talking about creating new output folders, yes, this is because Hadoop file system is read only, but this can be used as versioning. So if your program is correct and if you are satisfied with your output, then I don't see any reason why you would be executing it again because you already have output. So why would you execute it again? One thing. Second thing, if you're executing it again means you have made some change in the program. So in that case, having a new output folder can always help you in versioning, like we are doing, right? Every time we are executing it, we are giving it the same name, only we are changing the numbers 1, 2, 3, 4, so that we keep a
Yes.
track that okay, this is the first time when I executed a combiner ka program, second time when I executed a combiner ka program, third time when I executed a combiner ka program. So actually, this is a good thing that you can get. Look at the bigger picture. Think as a analyst. Go into the main functionality. And I am very sure that this disadvantage is already communicated to both of you because we are into a Hadoop analyst ka course. So the time I might have told you about the course, I am very sure that I have told you disadvantage. And I precisely remember communicating this to at least Madhuri as well as Mangesh, both of you. Yeah, Madhuri, I have done this. Yes, and Mangesh, I'm very sure I have done this. How does this look like a disadvantage? What say? Is this a disadvantage? Guys, you can go on mute when not talking, please. There's a lot of background voice. Is this a disadvantage? See, Hadoop was built for analyzing big data. Hadoop framework was never built with a point of view of application development or application design. It was developed with the point of view of analyzing this big data and solving the big data problems. So main thing was the people who started using Hadoop or the people who would ever use Hadoop would be people interested in statistics, analysis, graphs and charts, and not interested in programming language. So they would be people having background in managerial activities and not in development activities. So if you tell them to learn any programming language and work on it, it is surely going to be difficult for them to do it. But if you're telling them to learn Java, which is by far the most tedious language ever, by far the most difficult language ever to learn. So if you're telling these people to learn Java so that they can work with Hadoop, then nobody is going to be interested in working in Hadoop. Because as far as I know about Java, and as far as I have communicated or had this words with the Java developers, then one thing is very clear. There are only two possibilities if you learn Java. One, you will like Java so much that you won't get into anything else other than Java. You will be completely focused with Java and you'll stay in Java itself. Second, if you don't like Java, you'll get frustrated so much that you won't go near anything that has the word Java into it. This is the experience that I have with Java. So the main disadvantage of MapReduce programming was coding in Java. Secondly, it also had disadvantages with respect to the model as well. Even the model had the some disadvantages. So can you now tell me what was the disadvantage in the model of MapReduce programming? Give a guess. Come on, guys, you need to seriously work out now. Yeah, somebody went on unmute.
Is about the yeah, this is regarding the compilation, because even if you make any changes in the code, unless you execute that through the dashboard, you won't be seeing any error messages.
Not exactly. You can test your program initially itself by compiling it in Java, because that is anyways a Java ka program, so we can compile it. And we would also be having a looking at testing of that program in a small, very small introduction, thing called as MR unit. A very
Mhm.
small topic it is. MapReduce unit testing. You're not looking at the broader picture. Provided you guys don't devote this Saturday and Sunday for this revision and for doing whatever we have done so far, and it is going to be difficult because you will be getting assignment as well today, so it is going to be difficult, but provided you don't study, Monday is going to be interesting for me. Provided you don't study, Monday is really going to be very interesting for me. So guys, basically if you talk about the model of MapReduce programming, then it is rigid. Rigid in the sense that the phases are fixed. You always have to flow like first map, then shuffle and sort, though it is internal, but still it has a lot of importance in making this rigid, and then reduce. Not completely customizable. The reason is shuffle and sort has a fixed input and fixed output format. Okay, because of this, your maps input or maps output rather, and reduces input formats cannot change. So your mapper's output format and reducer's input formats cannot change because shuffle and sort has a fixed input and output format. And that's why it is not completely feasible, not completely customizable. And because of this, it is difficult to model all real world applications using MapReduce. Moreover, we have also seen that all problems cannot be solved using a single MapReduce program. Means what? We saw in the first sample program that we ran, right? The Hadoop examples wala, that we ran one program, but internally the program was split into two, and one execution triggered the other execution. So it was a pipeline of MapReduce programs. So all your problems cannot be solved using a single MapReduce program. So these were some of the disadvantages of MapReduce programming. Is this clear now?
Yeah, clear.
Yes.
Are these disadvantages?
Mm.
Yeah.
So why didn't we get any of these? Is it something which was never clear from the things that we did so far? Or is it we did not think with that perspective? Or is it something that was not explained to you when briefing about the course?
There's only some practice is needed from our side.
Not some practice, a lot of practice is needed from you guys' side. I'll be sharing around one, two, three MapReduce programs to you apart from what we have done. And those three MapReduce program won't be documented. They would be just programs. You will have to, okay, let me do it. Just give me 2 minutes. Let me explain you what is going to be the assignment. Okay. So these are the two programs, and apart from this, there are more two programs in which I'll be just giving you the data set, and I will be giving you the problem statements, and you will have to design the MapReduce program. I do have the code with me as well, but I won't be sharing that. I would just be sharing the problem statement, which would be a single liner problem statement. Find out all phone numbers who are making more than 60 minutes of STD calls, for example. Okay, so it would be very simple MapReduce problem statement that I would be giving it to you, and from that you will have to design a MapReduce program. So there would be two for sure, and total of 4 or 5 of MapReduce programs that you would be getting as a this thing test, not test, as an assignment, and as a part of your test. Where is that gone now? Okay, and I do also have the test killer problem statement, something like this, similar to this, but a bit complex one, ready with me. Okay, so even in that, you will be getting only a problem statement, and you will have to write a MapReduce program for that. Okay, now you don't have to be worried on this in a sense that you don't know Java. You don't have to be, get tensed. कि, okay, I don't know Java, then how can I do this? Because everything is going to remain same in the programs. The entire structure of your map program, your reduce program, your main program, main class, map class, and reduce class is going to be same. What will be changing is only the logic. What will be changing is only the logic, and this logic will get clear to you when you will do this 4 programs. When you will do this 4 programs, the logic would be clear to you. And for doing this 4 programs, you'll have to first try completely on your side. First try completely on your side, and completely trying into your side means you can refer Google, but please do not get the exact source code from there. I don't think that this is available because we have made some changes into and prepared it as of our own. So I don't think this will be readily available. But yes, still there's a possibility that it may be available. So if it is available, please do not use that, because then you won't be able to learn. So you can refer about some concepts from the net and prepare your MapReduce program. But when in the test, the logic should already be getting cleared by practicing on this 4, and Monday will be having a test wherein you won't get any option of referring on the internet because you won't get that much time of doing it. Okay, so plan your weekends straight away, because there would be 4 MapReduce programs that you would be executing, a lot of theory part to be studied, plus two of our not two, 4 of our normal labs that we did. So there would be around 8 to 10 tasks for you this weekend. Okay, sounds good.
Yeah, yeah.
Yes.
Okay. So these were some disadvantages to MapReduce programming. So what is the solution that we came up with? So what we thought of was, that why not so as a solution to our problems, we thought, why not abstract the complexity of MapReduce at the back end and give a simple interface at the front end, okay, and prepare libraries for uh, many of the problems that we normally use MapReduce for, and get MapReduce on a generalized level wherein you can run one command and solve one problem. Okay, so with this intent, it gave rise to Hadoop ecosystem family. So this solution's intent gave rise to the ecosystem family of Hadoop. So what is this ecosystem family now? It is a collection of tools that support the Hadoop framework. It is tools that use HDFS as storage. It is tools that have MapReduce programming at the backend. Then tools that, okay, it covers everything. So they are the tools that follow the same job process, the same architectural status and background, but at the backend. So Hadoop ecosystem family is a collection of tools that supports the Hadoop framework or that actually runs on the Hadoop framework. These are the tools that use HDFS as storage and have MapReduce programming at the backend. This is clear?
Yeah. Here.
So talking about these tools, some properties of these tools. These tools are application specific. They are installed on client or they are installed in their own servers. Means what? What is important is the ulta part, that they are not installed on the Hadoop cluster. So we won't be installing them on the Hadoop cluster. So these are simple tools. So we would be installing these tools either then in their own servers, which is done for only one of the tools, which is Flume. For rest, all other tools, they are installed on the client machine itself. They are application specific. They have MapReduce at the backend and they are installed on client machines. Clear?
Yep.
Okay.
When we say they are application specific, can you give an example for that?
Yes, I was coming on to that. So what is meant by application specific and why they are application specific? So first of all, what do they look like? Now what happened that let's say I'm good in singing. Okay, I'm not, but still let's say that I'm good in singing, and for singing, due to some reasons, we have to write MapReduce programs in Java. So for every song or every type of a song or every type of a stanza or every type of an antra, I have to write a MapReduce program. Okay, so I am good at writing MapReduce program as well. I am good at writing MapReduce programs as well. So what I did for around 150 types of songs or for 150 types of things or stuff in singing, I managed to write 150 MapReduce programs. So these were the 150 possibilities that I could think about singing, or these were the 150 possibilities in singing that I actually worked with. So that's why I was able to create 150 MapReduce programs. Then what I realized was that even Mangesh and Madhuri, some point down the line, will get into singing, and in that case, even they would be required to write this 150 MapReduce programs. And if they are not good at Java programming, then they won't be able to do those 150 tasks in singing, which I did. And then singing won't be popular. So what I did, I prepared more 150 commands. Each command was having the ability of triggering these 150 MapReduce programs. I'll show you in detail as well. So just listen to the story first. So what I did, I prepared 150 commands that had each of them had an ability to trigger the execution of these 150 MapReduce programs. Then I bundled all the MapReduce programs along with these 150 commands as a library, okay, as a library, and then I prepared a tool out of it and I released in the market. Now, whoever wants to do singing using MapReduce, he just have to know the 150 commands and he doesn't need to bother about the MapReduce programming. So we'll execute simple English like commands at the backend, which will trigger execution of this thing in the front end, MapReduce in the backend, sorry, and his work is done. Now, similarly, Mangesh knew how to dance. Mangesh is good at dancing. So what he did, even he realized that there are around 200 steps in dancing, and for every step he needs to write a MapReduce program. So he wrote those MapReduce ka 200 programs. Then he created 200 commands that can trigger those programs. Then he bundled them as library, made a tool out of it, and released in the market. Now, why it is application specific? Because Mangesh and Jayant can think about their application in n number of ways. They can think about their application in n number of ways, but they cannot think about all applications in n number of ways. So if we would have tried to prepare one tool which will have everything or which will have for everything MapReduce programs at the back end, then it would have been impossible. Moreover, it wouldn't have been efficient. Having MapReduce programs for everything at the back end is not a work of a single community. There has to be communities who will be dedicated on doing this in their own streams. So if there is a community of people who are good in SQL, then they will probably design a tool that will do all the functionalities of SQL without MapReduce. Similarly, some people are good at in PLSQL or some people are good at, let's say, website design. So they'll make sure that they design, their community designs a tool which can do website design without any code. That's why it was application specific. Means one tool can do only one sort of activities. one tool, if it is doing SQL, then it can do only SQL. If it is doing singing, then it can do only singing. It cannot dance. If it knows dancing, then it only knows dancing. It cannot sing. Clear?
Yeah, clear. But one question here.
Yeah.
If I'm using Hive,
Uh-huh.
say for example, for SQL related applications,
Uh-huh.
then that Hive should be having a capability to work for PLSQL as well. Means can we customize Hive to get it supported on some other applications? Is it open?
See, that would be a new version of Hive.
Yes, means many a times we do have out-of-box functionalities along with a tool, but again, based upon the application specific requirements, we might be having some access to modify that tool.
You have
So,
complete access to modify those tools because they are open source versions. And see, this is what it
okay,
is. See, you designed a tool which can do dancing. Okay. And Madhuri started using it. But Madhuri realized that your tool is not uh, suitable for doing Bharatnatyam. Madhuri came to know that your tool is not suitable for doing Bharatnatyam. So what she did, she said that okay, this is limitation of Dancing Tool 1.0. This is the limitation of Dancing Tool 1.0. So she prepared MapReduce ke programs that can do Bharatnatyam as well, and then she released it as Dancing Tool 1.1, which now knows Bharatnatyam as well, right? So these tools are all open source. These tools are all open source, freely available for use and freely available for modifications. So this is one of the primary reasons why today we have n number of ecosystem tools. Again, a disadvantage, but this we'll see at disadvantage in the later part in phase 3 when we'll be talking about distributions, not now. So, but even this is a disadvantage that today we have n number of Hadoop K tools. Okay, and the reason behind having n number of Hadoop K tools is that if Bharatnatyam was able to, if Madhuri was able to integrate Bharatnatyam in dancing tool within 4 or 5 MapReduce K programs or with adding less complexity, then she will release another version of dancing tool. But if she finds out that this tool is itself becoming too large to get integrated with the existing dancing ka tool, then she will release it as separate Bharatnatyam ka dancing tool. And then we have one more ecosystem tool. So talking about what you just said, Hive is only for SQL. Okay, Hive is only for SQL. You can write user-defined functions in Hive, which but they are not the PLSQL wale functions. You can write user-defined functions in Hive, but those are not PLSQL related functions. Okay, but you have a tool called as Pig, which does all the PLSQL operations. So earlier when Hive came in, it had a lot of limitations, and there have been a lot of revisions in the versions of Hive. Okay, with every new version, we have got some or the other upgrade. So these were the upgrades which had small addition of complexity, and that's why we could integrate it with the existing tool itself. But this PLSQL wala functionality stood out as a separate project itself because again, it is a vast thing to be integrated with something already present. So we have another tool for that. Now, if tomorrow, if anyone is using this and it finds out some new limitation out of it, and if he finds out a solution out of it, he is surely open to contribute it to the community and release it at its own new version or a new tool altogether. This is from where Impala came in. This is from where HBase came in. This is from where Spark SQL came in. Or instead of saying this is from where, I rather say this is how Impala came into picture, this is how Spark SQL came into picture, and this is how HBase came into picture from Hive. And talking about these limitations and new versions things, this is why you have Impala, this is why you have Mahout, this is why you have Kafka and all the second generation wale ecosystem tools. Storm, this, that, blah, 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 blah. Moreover, talking in the same path in which Mangesh you just queried. So today, not only the ecosystem tools have been modified, but even Hadoop has been modified in an application specific or a business specific way. So HP has its own Hadoop version. Then IBM has its own Hadoop version. Then Microsoft has its own Hadoop version. So these people do have their own Hadoop version available. So what they have done is, instead of getting on a generic platform, they have designed a Hadoop which can be available for, or which will work only specific to their platform or to their business functionalities, whatever they are up to. So similarly, you're open to do all the changes. The source code for every ecosystem tool is available in the documentation as well as on the GitHub ka SVN repository. So if you are a registered member of that, if you are a contributor to the community, then you do have rights and accesses to these. Only thing is, whatever changes you do, that cannot be sold. You can redistribute it again as free version, but you cannot charge for that. So that's why all the ecosystem tools are free. You can use it for your own purpose if you want and not release it into the market. But if you want to release it in the market, you cannot sell it. You'll have to keep it free. Clear? Your question is solved?
Yeah. Yeah. Yes, yes.
Okay. Just give me a second. Okay. So now clear on the ecosystem part.
Yeah.
Yeah.
Yeah. Okay. So everything is getting clear. But when I start asking questions, nobody answers. Okay, then we will be practicing this week. So let's see. Okay. So basically the backend working of all the ecosystem tools is same. Okay. So if we understand the backend working and design of the ecosystem tools on a general platform, then by just understanding the application specificness of these ecosystem tools, we can very easily, uh, understand any ecosystem tool available on the planet. So what we'll try to do is we'll try to understand first the backend of all of the ecosystem tools in general. So what you have is you need to drink water. Just a second. Okay, sorry. Actually, this is 2 minutes ka daily work for me. Unavoidable daily work for me. My maid comes in at this time, so I have to instruct her what is to be done. So sorry for this 2 minutes. Okay, so coming back. So hey guys, you're there, right? Hey, you can respond.
Yes, yes.
You don't need to be so serious. Now it's almost one end of second week together. We'll be soon completing 2 weeks together. So we are not new to each other now. So you can be open. I never saw you both talking to each other except yesterday. So come on, open up, guys. We are having very serious environment. Okay, chalo. I'll try to break the shackles. You don't even laugh if I crack a joke. Still not
You're
respond.
always on mute.
Uh, okay, no issues. So what we have is we have our client. You're always on mute because you are having the problems of fighter planes. So fighter planes don't allow you to fight.
Yeah. We have a lot many chorus around.
Right. And once take a selfie with this fighter planes and show it to me. I really want to see fighter planes. I never saw fighter planes. Even on the Pune airport, I was not able to see fighter planes anywhere.
Yeah, they share the same aerodrome, but the runways are different.
Okay. So where are they kept? They are not kept on that big ground.
No, they have a separate depot.
Okay. But still, you
If you
cannot.
no,
You
if you have been to the Pune airport, you have a domestic entrance and there is a
right.
separate entrance for the defense region.
I never saw.
It's exactly at the opposite end of the aerodrome. The
The
domestic entrance is exactly opposite.
canteen के यहाँ पे.
If you heard about this Lohegaon, the Lohegaon town village,
Okay.
from that side.
Oh, is it? But still, you are not allowed to click pictures in the domestic airport of Pune as well, saying that it is
No,
a military area.
yeah, that's a restricted area.
Yeah, but it is only in Pune. Rest all the airports you can click pictures.
Uh-huh. They do have a dummy model of this fighter plane Sukhoi. If I happen to go that side, I will click that.
Make sure that clicking is allowed, otherwise you will have to manage internet connection in jail.
They do allow a city bus to travel from one of the routes that goes inside that premises.
That sample
It's
thing we
about
have here as well, somewhere on the near Hadapsar. Madhuri, which is that area behind Magarpatta city? She stays in Hadapsar.
Behind Malapetta or which place?
Sorry,
Don't know. I don't know.
we have that one aeroplane kept there, one tanker kept there on the ground. Okay, it is behind Hadapsar somewhere, not behind Hadapsar, behind Magarpatta city back gate. So there we have one small plane captain and one tanker captain, but that is dummy. Dummy means that we have in museums,
hmm. Okay.
not an actual fighter plane. You know that we saw in Border movie.
Hmm. Okay.
Okay. So getting back with our ecosystem tool, this is our fighter plane that we should focus on. So what we have is we have our client, and on this client we will be installing any random ecosystem tool. Okay, on this client we would be installing any random ecosystem tool. So once you install this ecosystem tool, what you will get is you will get a shell. So basically a place from where you can execute the commands, and normally it is your same command terminal. Okay, normally it is your same command terminal, plus what we would be getting is so any commands of this ecosystem that you have to execute, you will be executing it on the shell. Then you will have a query engine which will consist of two parts. One would be the compiler, and second one would be the processor. So whenever you execute a command in the shell, that will go to your query engine, which will first go to the compiler and check whether everything is fine or not, the syntaxes and everything. Okay. Then this compiler will go to the processor. Then this processor knows that he would be having something called as a library. Okay. Now this library will have a lot of MapReduce programs. Let's say this is my MapReduce programs. And basically these would be jar files. Okay, so the library will consist of a lot of MapReduce programs. So first thing what you will do is from the ecosystem tool, you will execute a command in the shell. This command will go to the query engine wherein it would be compiled, and then the processor what it will do is it will go to the library. The processor will go to the library and it will fetch an equivalent MapReduce program from the available MapReduce programs in the library. Then you will also have your Hadoop cluster, which is essential. Okay. Then what will happen from this library? One of the jar file would be fetched in, or let's do this first. Let's pull this library out. Mm, so this processor will get this command. It will break it into two parts. One it will call it as logic, one it will call as parameters. So for the logic, what it will do is for this logic, it will go and search in the library. The logic part, it will go and search in the library, and let's say it gets a jar file out of it. Okay, let's say it gets a jar file out of it. Then what it will do is from the parameters, these parameters, it will pass it on as arguments to this jar file. It will pass these parameters as arguments to these jar files, and then this jar file would go and get executed on your Hadoop cluster, and after the execution, it will generate an output, and this output would be, what happened? Something went wrong. Just a second, it is hung. Machine is hanged, machine is hanged. It's good now. Would be given back to the client. Okay, so my diagram is complete. Just give me a second and I'll show you what is done. Okay, so basically what you have is you have your client and you have your Hadoop cluster. In your client, you will install an ecosystem tool by which you will get a shell and you will get a query engine which consists of a compiler and a processor. Now let's say you write a command in your shell. Okay, now let's say you write a command in the shell, then the compiler will check for all the syntaxes and issues in your command. If everything is okay, then the processor will break that command into two parts. One would be logic and other would be parameters. For the logic part, what it will do is it will go in the library and search whether you have any MapReduce program that can run on this logic or that can execute a that can execute this logic. Okay, then let's say it finds one jar file. Let's say it finds one jar file. Then what it will do is it will pass these parameters as arguments to these jar file. It will pass these parameters as arguments to these jar files, and then this jar file would be executed on your Hadoop cluster. in your Hadoop cluster, which will generate an output, and then the output would be given back to your client. So I'll call it as jar execution. Which will produce an output for me. And then this output is given back to your ecosystem client, to your client. Got it?
Yeah, clear.
So this is how your ecosystem tool runs. Now, if you try to do this, steps involved in execution of MapReduce का program, then you'll observe that, see, first time when we did the cluster ka setup, then what we did, the jar file was already available with us, right? The program was already written. It was already bundled as a project. It was already exported as a jar file. All we had to do was write a command and get it executed. Second time when we wrote we executed a word count ka program. That time what we did, the program was already written for us. We just created a project out of it and we executed it. We exported as a jar and then we executed it, right? Now when you would be doing the assignments, wherein you'll have only the problem statement, then you'll come to know of all the steps, which are writing the 3 class files, then bundling them as a project, then exporting them as a jar file, exporting the project, so it as a jar file, and then executing it on the cluster. Right? So basically these would be the steps involved in your MapReduce key programming ka execution. But what your ecosystem tells you is your ecosystem tools tells you don't worry about any of these steps. Ecosystem tells you don't worry about any of these steps. Instead, you write a ecosystem ka command and it will do all these 4 things for you. You just write a ecosystem ka command and it will make sure that all these 4 things are done for you. Out of which the first 3 things are already done in the library. And once you write a command, the compiler and the processor together will make sure to find out the resembling jar file out of it, and then it will get executed on the cluster. So this is how your ecosystem key working looks like. A completely detailed working of your ecosystem tools. Any doubt in this?
Yeah, about this output in the client side, like the output files are
Uh-huh.
stored on Hadoop cluster,
Yeah,
right?
it is stored on Hadoop cluster.
But the same
Displayed
file
on,
is stored
no,
near the
displayed to the
same.
client
So there should be an interface for looking into the output file which is stored on the cluster, right?
using your Hadoop browser.
Okay,
So using our Hadoop client or using our terminal, we are able to see the steps of execution, right?
right.
And using the browser or the terminal again, we can peep into Hadoop ka file system HDFS and see our input and output, right?
Yeah,
So similarly, when a program would be executed, or when an ecosystem tool ka command would be executed, on the terminal screen you will be able to see that a MapReduce program is getting executed. Though you have not triggered a MapReduce program by your own, but because it is getting triggered at the backend, you will see the same kind of interface which you saw when the MapReduce ka program was getting executed.
Okay, you mean to say the percentage completion of the map phase and the reduce phase,
Exactly.
or the job number?
Yes, the job ID, then the map phase, then the reduce phase. Then if you go in the job browser, you will be able to see that okay, these many maps were executed, this many reducers were executed. All this you would be able to see.
Okay, okay.
Plus, the output also would be visible on the terminal. If it is, if it's like something like SQL, wherein you immediately see the output on the terminal. Else, it would be available inside your HDFS.
Okay.
Any doubts?
Yeah, good so far.
Madhuri, clear?
Yes.
No doubts at all?
You will do the practical instead, then you
No, no.
appeal.
Not clear, not clear. Your voice is not clear.
Do practice and then you have to.
You will have to practice and then you will get droughts.
Yes.
Yeah, so you should be doing that quick enough. Okay. Okay, so talking about your popular tools and their functionalities. So the first one that we have is, let's go in the order that we are going to take. So first one that you have is Scoop, then you have Hive, then you have Pig, then you have Flume, you have Oozy. Okay, so you have Scoop, you have Hive, you have Pig, you have Flume, and you have Oozy. Now, what are their roles and responsibilities, or what are the applications that they work on to? So, talking about Scoop, it is nothing but a simple import export tool. Scoop is nothing but a simple import export tool. Means it can bring data from somewhere and put that data into somewhere. It can import data from somewhere, dump it in somewhere, and it can export data from somewhere and dump it somewhere. And that somewhere is between your RDBMS and HDFS. That somewhere is between your RDBMS and your HDFS. Okay, so basically Scoop can do an import from RDBMS to HDFS, and it can do an export from HDFS to RDBMS. So this is what your Scoop is. Talking about your Hive, Hive is nothing but SQL on top of Hadoop. Hive is nothing but SQL on top of Hadoop. So it gives you a number of functionalities of SQL programming. It gives you a number of functionalities of SQL programming other than updates. Except updates, you get a lot of functionalities of SQL programming. Why not updates?
HDFS is read only.
Perfect. Because HDFS is read only, you don't have the options of updates. You do have updates in recent versions of Hive, but those updates are again not actually updates. It is creating a new table out of the updates. So you're not updating the existing table, you're actually creating a new table around it. So this is what your Hive is. It is SQL on top of Hadoop. Then talking about pig is nothing but PL SQL on Hadoop. What does PL SQL stand for?
Procedural language.
Okay, procedural language in SQL. So what is this procedural language in SQL? Why do we use it? What is this? When do we use it?
Writing the functions of procedures as those are compiled. What you can say. The
What?
query will compile once
Mm-hmm.
and
Reusability of code.
reuse it. Yeah.
Okay. So if you already had SQL, then why did we invent PL/SQL? Or what is the basic difference between SQL and PL/SQL?
When we write simple SQL queries,
Mm-hmm.
every time to compile and execute it take much time as compared to PLSQL. In PLSQL, as we write any procedural functions, once it compiles, then for the execution of it, it doesn't take much time.
Not really. Precisely, that is not the case at all. Because the things that you do, but this would be the answer. No, no, your answer is not correct. Precisely not correct. SQL is rather more faster than PL/SQL in a sense. In a sense, SQL is much faster than PL/SQL. So that is not the reason why we had PL/SQL.
Every time when our SQL query will execute, every time it compiled and execute, what
Okay. So again the same answer, right? The answer is same on a similar grounds, I would say, but only you have shaped it different this time, framed it differently. Huh? Madhuri? Guys, tell me one thing. Even when we were talking today about the disadvantages of Java, uh, why don't we focus on the functionality? Why do we have to revolve around it? Hmm? So you just said, right? PL/SQL is procedural language on SQL. I would rather say PL/SQL is a programming language interface for SQL,
uh,
right? Just a second, guys. Okay. I would rather say PL/SQL is a programming language interface on SQL. Now this gives an answer to every question. First, using SQL for functionalities wherein you have to go for a for each or a conditional or a loop, then it is very difficult to get it. You can, You can get it by having implementations of your nested queries and implementation of joins, but then it becomes very complex and it becomes very slow. This is the reason why PLSQL is faster than SQL, because the same thing that you can do using for each, for loop, or if and else condition in a programming language is way too easy and faster than using a lot of joins and a lot of nested queries in SQL. Okay, to get this features of ease and speed in doing these conditional operations that are an advanced stuff on top of SQL, we invented PLSQL. Got it now?
Yeah.
Okay, so this is something that we already know. I just wanted you to shape it up nicely. Okay, so because SQL had some limitations on working with programming level concepts, we got PLSQL. So similarly, Hive is for SQL, and the limitations of Hive are kind of overcome by Pig. Not limitations. Pig gives you a more easy interface to work on. So you can do all the things that Pig does in Hive. You can do all the things that Hive does in Pig, but only the way of doing it is just different. Only the way of doing it is different, and the complexity as well as the time requirement is different. Then talking about Flume is nothing but a simple messaging service. So a messaging service is a gossip girl. So Flume is nothing but a gossip girl. He will get some gossips from somewhere and come and tell those gossips to our HDFS. Okay, so Flume is nothing but a messaging service or a gossip girl which will just go outside, listen to some gossips here and there, and then come to our HDFS and tell him those gossips. Okay. Lastly, your Oozie. Your Oozie is nothing but a workflow scheduler. So Oozie is nothing but a workflow scheduler, which knows how to schedule a given workflow, which knows how to schedule the step-by-step execution or the cron job kind of or daily scheduling of any workflow. It's like, every 5 o'clock wake me up. So that is what Uzi can do. Or let's say after getting up, start the class, after the class, have breakfast, then go to gym, then go to swimming, which I don't. Okay, but still, this is a workflow. So if Uzi would have been there, it would have scheduled it nicely for me. Clear?
Yeah,
Yes.
clear.
Okay, so these are the popular ecosystem tools that we would be studying from the next sessions. So that's all for this session. If you have any doubts, you can ask, else we can call it a day. Any doubts?
Yeah, one question, can we use multiple these ecosystem tools on the same client?
Yeah, you can have all, we will be having. You can have all the
Okay,
ecosystem tools on one client. Only thing is they don't have an internal integration together.
okay,
They don't have an internal integration together. That's it.
okay.
Okay, clear? Okay, so yeah, so long guys then. See you tomorrow. Have a good day ahead. And Mangesh, I'll just work on the dashboard ka issue with you. I'll get it cleared. So nothing, they just have to make an entry in the database and that would be done. So I'll be sharing the session document and the video for today's session very soon. Okay. So yep. Thanks a lot. See you tomorrow. Bye bye. Have a good day.
Hi, good day.
Bye bye.